Last chapter. We're asked to simplify these first few, and so we need to find something that's in common with all of these terms. And it looks like there's a 3 that goes into all of the terms. 3 goes into 12 4 times. 3 goes into 9 3 times. It goes into 6 twice. So we're left with 2x plus 3 all over 4. And that can't go any farther. In this equation, well, it's not an equation, it's a statement. We're going to factor the numerator, and I think you'll see it factors nicely into x plus 1 times x plus 1. Remember, the factors of multiply together to equal 1, add together to equal 2. The denominator, we can factor a 5 out of both of the terms here and here. We end up with 5 times x plus 1. At that point, I can go ahead and I can cancel out one of the x plus 1's, and my final answer then will be x plus 1 divided by 5. Alright, so we go ahead, we can't do anything with our numerator, so leave that. The denominator, I think you'll see, is x minus 4 times x minus 4. Now, 4 minus x in the numerator looks very close to what we have in the denominator. So I think what I can do is factor out a negative 1 from that numerator, change the 4 minus x to x minus 4. My denominator is still x minus 4, x minus 4. And now I can go ahead and cancel one of these out, and I end up with negative 1 over x minus 4. Now we're multiplying fractions, and I think I'm going to want to factor the left one, but before I do that, since it's multiplication, I can go ahead and cancel this one out. So then it makes it a little simpler. My denominator is x plus 3. My numerator can factor the factors of negative 12 that add up to negative 1. I think we're going to have x minus 4, x plus 3. We can then cancel out our x plus 3's, and we're left with, after all that, with just x minus 4. When we have a division problem, we go ahead and make it a multiplication problem by flipping this second term. All right, and I'm going to do that, and I'm going to factor all in one fell swoop. So the x squared plus 6x plus 8 is going to factor to x plus 4 times x plus 2. 2 times 4 is 8. 2 plus 4 is 6. The denominator, x plus 2, x minus 1. And now I'm going to multiply. I'm going to bring up that 2x plus 4 to the numerator. I'm going to factor a 2 out. I get x plus 2. The denominator is still x plus 4. And then I see what I can cancel out. My x plus 4 goes away. My x plus 2 goes away. And I'm left with 2 times x plus 2 over x minus 1, which is kind of this piece here, and I've run out of room. But if you think of that over that, that's our answer. For this problem, we have a fraction over a fraction, and we're going to make it, again, a multiplication. So I'm going to write that out. So there's our multiplication problem, but before we do any multiplication, let's factor and cancel things out. So the first fraction factors 4x minus 1, can't do anything with that. X squared plus 2x plus 1 factors to x plus 1 times x plus 1. X squared minus 1 we recognize as the difference between two squares, which becomes then a squared minus b squared, a minus b times a plus b. In the denominator, it looks like I can factor, I can't factor a 4 out, I can factor a 3. And I get 4x minus 1. And then I go ahead and love to do this, 4x minus 1, or 4x minus 1, x plus 1, one of the x plus 1's, and I'm left with x minus 1 in the numerator and 3 times x plus 1 in the denominator. You can either leave that like it is, or you can distribute the 3 to the two terms and get x minus 1 over 3x plus 3. we have a long division problem. And what do we need to multiply 3x by to equal 3x cubed? And that would be x squared. So x squared times 3x minus 1 equals 3x cubed minus x squared. We're subtracting. Let's put this x squared up here. When I subtract, that becomes 0. This becomes positive negative 9x squared. I bring down, you see I left a spot here for my x term, even though there weren't any. So plus 0x. So now what do I need to multiply 3x by in order to get negative 9x squared? And that's going to be negative 3x times 3x minus 1. Gets me negative 9x squared plus 3x. Subtracting. This becomes 0. That negative out front here makes this 3x and negative 3x, so minus 3x. Bring down my 4. And it looks like I got to write up that minus 3x up top. And I'm going to have to multiply negative 1. And the negative 3x goes away. 1 becomes a negative 1. So I have a remainder of 3. So I have minus 1 with a remainder of 3. And that would be my answer. This problem I'm adding two fractions, but they are not the same denominator. So I must multiply the first term by x minus 6. X plus 6 over x plus 6. And I multiply the second term by x minus 3 over x minus 3. So let's go ahead and do that. The first term comes out to be 4x plus 24. I need to FOIL the second term. So x times 2x, there we go, there, is going to be 2x squared. I'll have 2x times negative 3 is going to be negative 6x. And then another negative 3x, so minus 9x. And then plus 9. And they're both going to be over. Actually, I'm going to erase this. I'm going to connect these two, because they're all over the same denominator now, so I can just write it as 1. Okay? Now I'm going to combine, and there's a plus sign there. Now I'm going to combine the numerator. I have, see, there's a 2x squared. I have minus 9x positive 4x, so minus 5x. 24 and 9 is 33. And this is already factored. I'm going to leave it factored just to see if something is going to cancel out. And looking at the numerator, well, let's see if it does, if I can find out some factors. 2 times 33 is 66. So let's go the old-fashioned way. And what are the factors of 66 that add up to negative 5? Well, I have 11 and 6. Whoops, 11 and 6. But that doesn't work because they're either both negative or positive, so that one doesn't work. Nope, doesn't work. 3 and 22, the difference isn't 5. I don't think it's going to factor, so I believe your final answer will be that. Alright, for B. In this problem, I'm going to need to multiply the first term by x minus 2 over x minus 2. You notice, this equals 1, so I'm not changing the value of it. I'm going to multiply the second term by x squared over x squared. Alright, and what do we get? First term is going to end up to be 4x minus 8 minus 7x squared all over x squared squared times x minus 2. Let's see if that numerator factors. Or let's rewrite it first. What is negative 7x squared plus 4x minus 8 over x squared times x minus 2. Now, if I factor the numerator, the only one that's going to work and cancel out if I have an x minus 2. And if I haven't, let's see if that would work. And the only way it would work, if I use this x minus 2 in the numerator, the other piece of it would have to be negative 7x, so I get my negative 7x squared. The 4 and the 2, negative 2, and the 4 to get negative 8. But if I FOIL that, I don't get what I have in the numerator, so we're done when we're there. Alright, in this equation there's an equal sign right here, which means we're going to solve. So what I'm going to do is I'm going to multiply everything by x to get rid of my denominator. Okay? When I multiply 5 by x, I get 5x. When I multiply x times 2 over x, the x's cancel out. I end up with 2. And the same thing will happen when I multiply 17 over x by x. The x cancels out. So this will be equal to 17. Take away 2 from both sides. 5x equals 15. X equals 3. 5b, again there's an equal sign, so I'm going to be solving for x. I think what I'm going to need to do is multiply to get rid of the denominators. Multiply everything by x plus 2 times x. So when I do that, I have x plus 2 times x multiplied by x over x minus 2 minus x plus 2 times x times 1 over x equals, again, the x plus 2 times x times 1. So we'll multiply that out. Or well, actually, let's cancel things. So x plus 2 cancels out. First term becomes x squared. Second thing, x cancels out. So I get minus x minus 2. Don't forget to distribute this negative to both terms. And this is going to equal x times x plus 2, so x squared plus 2x. Now, let's take away an x squared from both sides. So they go away. That's kind of nice. Let's add an x to both sides. So I end up with negative 2 equals 3x, or x equals 3 over negative, actually, let's do that on the other side. X equals negative 2 over 3. Alright, in this we're asking a question about indirect variation. We remember that the general form of that is y equals k over x. In A, it says find the constant of variation, so find k. When y is negative 8, and x is negative 32. So we're going to multiply both sides, or the whole equation, both sides, by negative 32. And we get k equal to 256. So our part B, what does the equation look like? Well, y equals 256 over x, so that would be B. C, I want to know what y is when x is 10, so all we do is we plug in 10 for x, and we get y equals 25.6. That's it. So we're asked to graph this equation, and I think what's important first is to find the domain and range for this equation. And the domain, again, whatever x can equal. In this case, what can x not equal? And x can never equal 4. It's all real numbers besides that. Y will never equal 0 because I cannot make the numerator 0 in this case. So let's graph it. Let's do it over here. Alright, and okay. So x cannot equal 4. So we're going to do a asymptote there. Y cannot equal 0, so there's another asymptote for us. Now I need to find some points. Let's plug in some points bigger than 4. So plug in 5 first. So if I plug in 5, I get y equals 6 over 5 minus 4, or 6. So 5, 6 is going to be up here somewhere. Let's plug in, how about 10? So 6 over 10 minus 4 is going to equal 1. So 10 is out here somewhere, 1. This piece of the curve is going to be going like so. Now I need to try some points to the left of negative 4. So let's try negative 3. So if I plug in negative 3, I get 6 over negative 3 minus 4 is negative 7. So negative 6/7. So it's very close to the, oh, that's not right, sorry. I plugged in negative 3, I meant, well, we can still use that point. Negative 3, it's very close to the x-axis. And I really wanted to plug in 3. So 6 over 3 minus 4 can be negative 1, so I get 3, negative 6. So it's down here. This side of the curve is going to go like so. And again, they're restricted by those two asymptotes. Alright, the last problem. Y equals 3 over 2x minus 6 minus 4. Again, the domain. What can x not equal? Well, it cannot equal 3 because that would make the denominator 0. The range. I can never make this part of the equation equal to 0, which means y can never be negative 4. So there are my two asymptotes. Draw it over here. 1, 2, 3, 4, 5. 1, 2, 3. So x cannot be 3. Y cannot be negative 4. So there's our asymptotes. I didn't give myself a lot of room here. But let's plug in 4 for x, which would be, let's get 3 over 2 times 4 is 8 minus 6 minus 4. So that would be 3 over 2 minus 4. So it's going to be negative 2.5. So 4 negative 2.5 is going to be around here. If I plugged in a really large number for x, let's say 3 over 20 minus 6 minus 4, I get 3 over 14 minus 4. You see it's getting closer and closer to negative 4 as I go farther out on my x-axis. So I think we're going to look at it like this, and it's going to go boom. Now I try some points to the left of positive 3. Let's try 0. If I plug in 0, I get 3 over negative 6 minus 4, which is going to be negative 4.5. So it is below that other asymptote. So 0, so right here. And I think if I found the points here, I should find a couple more, run out of room, it's going to look like that. That's it. Good luck. We'll see you on Thursday.